The world of AI is absolutely buzzing with what we call agents, those sophisticated AI systems designed to tackle complex, multi-step tasks that usually demand human intelligence. But here's the thing. Behind all the excitement, there's a big, often overlooked challenge. How do we actually know if these agents are effective and what genuinely makes them good at what they do? Today, we're taking a deep dive into a fascinating new study from the OPEO AI agent team titled OAgents, an empirical study of building effective agents. They've taken a truly rigorous scientific approach to answering exactly these questions, and their findings are quite eye-opening.
Yes, they really are. The core mission of this deep dive is to unpack why it's been so difficult to compare these AI agents reliably,
Mm.
identify the specific design choices that genuinely boost performance, and also introduce a new framework that aims to set, well, a higher bar for the entire field. It's truly striking how much impact those subtle, often overlooked details can have on an agent's success.
Yeah, the unseen factors. We're going to explore their systematic study on popular benchmarks like GAIA and BrowseComp, revealing which components are crucial and which, surprisingly, might be redundant even if they seem like logical additions. This isn't just about speed, right? It's about getting to truly robust and reproducible results in agentic AI.
That's the heart of it, robustness and reproducibility.
Okay, let's unpack this then. The paper highlights a pretty significant issue in current AI agent research. Despite a surge of interest and a flurry of open-sourced frameworks popping up, there's a real lack of scientific rigor and standardization across the board. It almost feels like the Wild West of AI sometimes, you know?
It does feel a bit like that. And this begs the question, why is it so difficult to conduct fair comparisons among methods in this space? Study points out that critical components like planning, memory, and tool use vary so widely across different papers and frameworks. This makes it incredibly hard to pinpoint what truly drives performance improvements. You're essentially comparing apples to, well, very different fruits.
That's a great analogy. And on that note, what did the study specifically uncover about how difficult it is to replicate results, especially with open source projects? Were there particular unseen factors at play, as you mentioned earlier?
Absolutely. They found that even open source projects struggle quite a bit with reproducibility. Factors not often mentioned in technical reports. Things like the specific implementation details of tools and prompts, or how many runs are performed, even just how errors are handled. These can lead to significant variance in results. Sometimes this impact is even larger than what new architectural innovations bring to the table.
Wow.
That's almost like having a recipe, but without knowing the exact oven temperature or the quality of ingredients, your cake comes out completely different each time.
So are you suggesting some of these widely touted innovations might actually be more about clever engineering hacks than fundamental architectural advancements? That sounds like a huge hurdle for the field.
It's a fair point to raise based on their findings. This fragmentation ultimately undermines scientific progress. It can turn research into a search for those tricks on engineering details, rather than a clear understanding of universally effective best practices. The result is that it's still very unclear how to build truly effective agents reliably.
So to tackle this rather messy situation, the OPPO AI agent team didn't just point out the problems. They built a tangible solution. They developed and open-sourced OAgents, a new foundational agent framework. What's their approach with this?
Right, so this framework is really the cornerstone of their systematic empirical study. It allows them to carefully compare different designs on key components like planning, tool use, memory, and various test time scaling strategies. They also investigated the impact of different large language model, or LLM, backbones and various evaluation practices. It's a bit like setting up a shared laboratory space, where everyone was previously doing their experiments in their own garages, using different equipment.
Right, bringing some consistency. And the ultimate goal of OAgents then is to promote what they call apple-to-apple comparisons and standardized evaluation protocols, hopefully making agentic AI research genuinely more scientific. It sounds like they're trying to bring some order to that Wild West you mentioned.
That's the aim. And to further understand effective agents, the study introduces this dual-axis analytical paradigm. It consists of factual acquisition capacity, or FAC, and logical reasoning fidelity, or LRF. FAC quantifies an agent's ability to retrieve, validate, and integrate external knowledge. That's mainly governed by its tools component. LRF measures an agent's capability to maintain rigorous causal relationships and deduction chains during complex problem solving. And that's where its plan, memory, and test time scaling mechanisms all work together synergistically.
Okay, FAC and LRF. That gives us a clear framework for understanding the mechanisms behind an agent's performance. Let's start with FAC then. This is all about how well an agent gathers and uses information from the outside world. What did they find here?
Well, a key finding was the importance of a multimodal toolkit, one that can process text, speech, images, and video directly, rather than just converting everything to text first.
Ah, so handling the raw formats.
Correct. On GAIA, multimodal tasks, OAgents with this toolkit achieved 74.07% accuracy. That's significantly outperformed a baseline, which was down at 48.15%.
Wow, 48 to 74, that's a huge jump. And you mentioned something truly astonishing earlier about audio tasks.
Yes, this was quite remarkable. In certain audio question answering subtasks, specifically those requiring temporal reasoning, the accuracy leaped from 0% all the way to 100%.
0 to 100%, that's incredible. It shows how crucial native modality processing can be.
It really does.
Okay, so beyond just multimodal input, a massive part of an agent's factual acquisition comes from web search. And here, the OAgents team built a sophisticated search agent framework with 3 optimized subsystems. Let's start with how they handled multi-source retrieval.
Right. Their approach to multi-source retrieval involved integrating commercial APIs like Google and Bing, alongside archival systems like the Wayback Machine. They found that diversifying search sources, for example, using 5 sources including Bing and Baidu, consistently improved retrieval accuracy.
Yeah.
The largest gain was actually in the harder Level 3 GAIA tasks, seeing a 7.69% increase there.
So more diverse sources help, especially for complex queries. Makes sense. What about optimizing the queries themselves?
Good question. They introduced a query optimization pipeline. This combined reflection for calibrating specificity, like is the query too broad or too narrow, and expansion for generating semantic variance. So different ways of asking the same thing.
And did that help?
It did. This strategy yielded a 7.55% improvement in Level 1 tasks and about 2.31% in Level 2.
Interesting. And finally, they looked at minimalist browsing. This sounds counterintuitive. Reducing complexity.
Yeah, it does seem that way. They reduced the browsing actions to just 3 atomic functions: search, visit, and read. The paper suggests this can improve robustness without sacrificing functionality.
So instead of a Swiss Army knife of browsing functions, they found focusing on just these 3 simple actions improved robustness. Simplicity winning over feature overload.
It appears so in this context. It confirms that sometimes less is more when it comes to tool design for these agents. And what's particularly insightful here is how these FAC improvements, the multimodal toolkit, the refined search agent, they significantly elevated OAgents' performance across various base LLM models. With Claude 3.7, for instance, OAgents saw a substantial 20.61% boost in its average GAIA score.
20% boost just from better FAC components. That really underscores how foundational factual acquisition enhancements are.
Absolutely foundational.
Now let's pivot to the other axis, LRF, the agent's ability to reason, plan, and remember effectively. What did they discover about dynamic plan generation?
They looked at several strategies here. One was strategic plan review. This involves iteratively revising plans every few steps based on new observations, rather than sticking rigidly to an initial plan.
Like checking your map as you go.
Kind of, yes. And this improved overall accuracy by about 3.64% over static workflows.
Okay, what else?
Then there's subtask decomposition. This involves breaking down main goals into smaller, interdependent subtasks, often visualized with the dependency graph. This showed around a 2.42% improvement. Makes sense for complex problems.
And I remember reading about something called plan tips. This sounded interesting using past failures.
Yes. Plan Tips integrates experiential knowledge from historical execution failures into heuristic guidelines, like little notes to self for the AI.
Learning from mistakes, basically.
In a structured way, yes. And this contributed to a substantial 14.54% performance improvement, especially for high-complexity tasks.
14%. That's significant. It's like giving the AI a bit of wisdom from past mistakes.
That's a good way to put it. Then for the memory-augmented knowledge system, OAgents utilizes a hierarchical memory module. It includes current memory as a short-term buffer, memory summarization, vectorized memory retrieval for finding relevant past experiences, and long-term memory.
So different layers of memory. Did adding them sequentially help?
It did. Their study showed a clear path to sequential performance gains. Adding summarization provided an initial, small boost. Retrieval pushed it further, and their long-term memory component proved most impactful, ultimately raising the average accuracy in their tests to 55.76%.
Okay, so memory matters, and structured memory matters more. What about pushing the agent harder? during the test itself, this test time scaling or TTS idea.
Right, TTS involves mechanisms like diversity enhancement and optimization at test time. One approach is diversity enhancement using a mixture of agents sampling strategy. Think best of n, or BO4 as they used.
So run the agent multiple times and pick the best answer.
Basically, yes, best out of 4 attempts in their case. This achieved the best overall performance gain of 5.19%. It particularly benefited simpler tasks, showing a 9.44% improvement for level 1 tasks. It's essentially throwing a few different attempts at the problem and picking the winner.
Seems practical, but they also looked at reflection during test time, right? Like real-time self-correction.
They did. But here's another one of those counterintuitive findings you mentioned earlier. The study notes that this particular reflection mechanism actually degraded results on the complex level 3 tasks by about 6.62%.
Degraded, so more thinking isn't always better, especially under pressure.
It seems so, or at least this specific implementation might introduce instability in complex reasoning chains. It really challenges a common assumption and shows the importance of empirical validation.
It's a really crucial point. We often assume more complexity or more reflection is always better.
But this component-by-component analysis shows a clear pathway to enhancing an agent's, let's call it, thinking process. Even if some strategies have nuanced effects across different task complexities, as we saw with reflection on level 3 tasks.
So after all this meticulous testing and component analysis, putting it all together, what does this mean for OAgents' overall performance? How did it stack up against others?
Well, the systematic study culminated in OAgents pass at 3, achieving the highest overall average score of 73.93% on the GAIA benchmark.
73.93%. How does that compare?
That places it at the state-of-the-art among both open-source systems and even leading closed-source systems reported in the paper, like Langfun Agent at 71.52% and Trace Agent at 70.3%.
So top of the leaderboard, basically. And it wasn't just GAIA, right? What about the web browsing benchmark?
Correct. OAgents also significantly improved web browsing abilities on the challenging BrowseComp benchmark. For instance, OAgents using GPT 4.1 or Claude 3.7 achieved 22.22% on the BrowseComp subset.
22%. How good is that compared to others?
That's a significant jump from baselines mentioned in the study, which ranged from about 4.76% up to 14.29%. So a really substantial leap in practical browsing capability.
It's impressive. But you mentioned earlier the issue of evaluation protocols. How does OAgents address that?
That's a key part of their contribution, beyond just the raw numbers. The paper importantly calls out the inconsistency in evaluation protocols across the field. You see some studies reporting pass at 1, others pass at 3, or pass at 5. For our listeners, pass at K essentially means the agent successfully solves the task within K attempts.
Okay, so comparing pass at 1 score to a pass at 5 score isn't fair.
Not at all. OAgents clearly states its result under specific pass at K settings, like the pass at 3 score we mentioned. This pushes for greater transparency and reproducibility in a field that desperately needs it. Their attempt to replicate another framework, small agents, and noting a significant performance degradation also underscores this point about reproducibility challenges.
Right. It highlights the urgent need for a more unified approach to testing these agents.
Definitely.
This deep dive into OAgents really highlights the painstaking work involved in building robust AI agents. And it underlines that critical need for standardized scientific research practices. It's a testament to moving beyond hype and into rigorous empirical study.
It really is. It's striking how much performance relies on these carefully engineered components and evaluation methods, and how sometimes the most logical or intuitive solutions aren't always the most effective across all levels of task complexity. It truly is an empirical science.
Ultimately, OAgents provides not just a high-performing framework, but perhaps more importantly, a methodological blueprint. A way for researchers to truly understand and build upon each other's work more reliably. It feels like a foundational step towards more dependable and effective AI agents.
I agree, it's a significant contribution. And this leads us to a thought for you, the listener, to maybe ponder. Given the detailed insights we've discussed today, particularly on planning, memory, and tool use, which specific design choice or component would you consider implementing first if you were tasked with building an AI agent for a complex, real-world problem? Something to think about.